Hi everyone, I'm going to do a review of the Unit 5 Part 2 test so that we can go over the important topics that you'll need to know to answer those short answer questions correctly. First, we'll start with the concepts that you'll need or the terminology that you'll need in order to answer the question. So we start out with ways that we can transfer temperature, and those are called conduction, convection, and radiation. We explained in class that radiation is like sitting by a campfire. When you are sitting close to the heat, it feels very warm. As you move further away, that energy starts to dissipate and takes longer to get to you, and it doesn't get to you as efficiently. So radiation is the movement of energy kind of through rays, waves, or particles. So this is our definition of radiation over here. Conduction is when something is directly touching the source of the heat. So the transfer of heat or electric current from one substance to another by direct contact, and that's called conduction. We see conduction in several ways. In this case, the person is touching the hot handle to the pot, and the pot is it could be directly touching the flame. That could be conduction, or conduction could be, the handle gets hot through radiation, and then your hand gets hot by directly touching the handle. The third is convection. We already saw convection through Unit 2 when we looked at plate tectonics and the movement of the mantle or the material in the mantle layer. And it's the transfer of heat through a fluid, which could be a liquid or a gas, caused by molecular motion. So here in this pot of water, the molecules that are closest to the fire are the hottest. Their temperature is increasing, which means they're moving around faster. Their density is decreasing, so they're starting to spread out. And as those molecules spread out, they move up, right? The less dense material rises in this solution. So the less dense water rises up to the top. And as it does that, it moves away from the heat source. It moves away from the fire. And so it begins to cool down. And that creates a flow in this circular pattern. So as the molecules become more dense, when they cool off, they go back toward the source of the heat. The heat makes them heat up and makes them become less dense, and so they rise up. And this pattern is evident in even things like the Earth's mantle or in something like a pot of water. Okay, so we're going to look at, or in the air, in the atmosphere, and that's where we're focusing in Unit 5. One of the questions in your unit test part 2 from Unit 5 talks about sea breezes and land breezes. So let's go over that. A sea breeze is when the air circulation pattern moves from the sea toward the land. So think about a day where you're sitting at the beach. You might be kind of sitting right at the edge of the water, and you feel the water blowing in from the water toward you. The reason that it's doing that, it has that pattern, is because of the way the land absorbs heat differently from water. It takes water a long time to absorb heat energy. We learned that back in biology. In chemistry, you probably talked about that, and we even covered it earlier in this year. Water has a high specific heat, so it takes water a long time to warm up. So when the sun rises in the morning, the water is starting to absorb energy, but it takes a really long time to do that. Whereas the land heats up pretty quickly. You know that because if you go walk across the beach, if you walk across a sandy beach, the sand can be really, really hot. It can burn your feet, and then you jump in the water, and the water feels really cool. So the water heats up more slowly. As the air above the land is heating up, its pressure is decreasing, right? It's becoming lower in pressure because we just talked about how when molecules get hot, they move faster, their pressure or their density decreases, and so they move upward. So as that air rises over the land that is hot, it moves away from the heat source. And so it starts to form that convection current. As it moves over the water, which is cooler than the land, it begins to cool off and sink down. And so we get this circulation pattern. So if a boat were trying to enter a harbor, it would make sense to do that during the daytime because this pattern of a sea breeze is going to exist. The high pressure from the cooling air over the water is going to blow inward. As it reaches the land, it will heat up because the land is getting warmed by the sunshine faster than the water is. that hot air is going to rise up and it's going to begin this convection current. Okay, so that's called a sea breeze. At night, we actually see the opposite pattern take place. So at night, the land cools off very quickly, whereas the water is still warm from the day in comparison to the land. So the same thing, if you take a walk on the beach at night, the sand will probably feel much cooler. This creates an opposite circulation pattern. So if you were on a sailboat and you were trying to leave a harbor, it would make more sense to do that in the evening. The land is cool, so the air is going to become more dense as it moves over the land. It's going to sink and it's going to blow across the water where it heats up. So the water is warmer, the air that touches the water is going to heat up and rise. It's going to move up and then again create that convection current just in the opposite direction. I'm going to put these two diagrams next to each other so that you can kind of get a comparison of what happens. Land and sea breezes are just natural occurrences that happen based on differences in the temperature over land and water. Sea breezes occur during the day when the land heats more rapidly than the water. This results in the pressure over the land being lower than the pressure of the air over the water. So here is our sea breeze during the daytime. The warm land heats up that air, it sinks as it moves, the air sinks as it moves over the water, and we create this circulation pattern. So boats can easily move in toward land during the day, and the opposite is true. Boats can move away from the land at night. This has nothing to do with tides. So high tide, low tide, not relevant here. We're talking about the air. So this would be like useful for a sailboat. We're talking about the air pushing the sail in toward the land or out toward the sea, depending on whether we have a land breeze or a sea breeze taking place. Okay, the last part of the test asks about albedo, and we said albedo is the reflectivity of a surface. So how much sunlight or how much heat is reflected away from a surface. And we mentioned in class that some surfaces absorb more heat. So if we compare here the asphalt or blacktop compared to grass, we know that black substances absorb more heat. So this is going to feel hotter because it's absorbing more energy. Things that do this have a very low albedo, whereas the grass here has a higher albedo. It's going to reflect more of the light away and it's going to feel cooler. So the percentage of radiation reflected from a surface is called albedo. Highly reflective surfaces such as snow and ice have high albedos. That's why on our scale down here, from a scale of 0 to 1, 1 being the highest albedo, we see the North and the South Pole have the highest albedos. They have the most snow, so they're going to be reflecting the most light away. Highly absorptive surfaces such as sand and forests, those are the darker areas, and in comparison, asphalt is darker than grass, but compared to ice, if we look at like white snow, it is lighter than grass. So the forests that are in these kind of tropical areas here, north and south of the equator, they have lower albedos than the poles at the north and the south. So highly reflective surfaces like snow reflect away light, whereas the low reflection from the forest absorbs the light. I hope that information is helpful, and if you need any help with that Unit 5 test, please let me know. Take care. Keep up the great work.